What's up, YouTube? Welcome back to Intuition. Today's video, we're going to continue solving Naplex problems. Specifically, we're going to be going over acid-base chemistry to sharpen up our math skills. Stay tuned. Alright, so in today's video, we're going to answer two questions on acid-base chemistry to make sure that we're comfortable with the equations and that we actually understand the concepts behind these equations. Okay, so with that said, let's dive into question number one. So question number one states, the above equation is the Henderson-Hasselbalch equation for a weak acid, HA, with a pKa of 3.8. Correctly identify the dependent and independent variables of the above equation. Okay, so it sounds like a pretty simple problem, right? So in this case, we need to know what the terms dependent and independent variable mean. Okay, so what do those mean? To understand the meaning of those variables, you want to put yourself in the position of a researcher. So imagine you're a scientist and you're trying to verify an equation, or you're trying to verify a relationship between two different parameters. If you were to go out in the field and verify this equation, which variable would you have control over and which variable would you not have control over? So when you look at this equation, what do you as the researcher have control over? Well, you as the researcher will have control over the pH. For example, you can squeeze lemon juice into a cup and you know that that will have a specific pH. Lemon juice would be acidic, and you can take a litmus paper to measure the acidity of the lemon juice, and you will know what the pH is, and you will have control over what the pH is. Because if you want to have a basic pH instead of an acidic pH, instead of dissolving the drug in lemon juice, you might dissolve it in an ammonium solution, and you would make a basic solution. So what you as a researcher have control over is called the independent variable. Usually equations are written in terms of the dependent variable is equal to some function of the independent variable. So when you look at this equation, it says pH is a function of the log of conjugate base divided by the acid concentration. So it looks as if the dependent variable will be the pH, but really the pH is the independent variable, because typically the pH is already set. The pH of an environment is set. For example, if the drug is in the stomach, the pH of the stomach is equal to 3. If the drug is in the intestine, the pH is already set in the intestine. In the intestine, the pH is about 7.4. You see, the pH is already set. That is the independent variable. And the dependent variable will be the concentration of the conjugate base divided by the acid concentration, because that ratio is going to fluctuate based on where the pH is set. So you can set the pH to whatever you want to, and that ratio will alternate based on what the pH is set to. So the independent variable will be the pH, and the dependent variable will be the relative concentration of the conjugate base and the acid. All right, so when you look at these answer choices, the correct answer choice would be answer choice B, right? The pH is the independent variable, and the conjugate base over the acid concentration is the dependent variable. All right, so let's dive into question number two. Okay, question number two states, which of the following equations is equivalent to the above equation? Select all that apply. Okay, all right, so in this question, we're basically given the same equation, right? We're given the Henderson-Hasselbalch equation for a weak acid, which has a pKa of 3.8. So that's the equation that we're given. Now, this equation could be rearranged and manipulated in different ways, but it still has the same meaning. So we're being asked to filter through these answer choices to figure out which one of these equations are simple manipulations of the above equation. Okay, so let's take a look at the first equation. The first equation says POH equals 10.2 plus the log of conjugate base over acid. Okay, so what do you guys think about this one? For a lot of people, maybe when you look at this equation, you might automatically say, well, this one has to be wrong, because POH is seen in the Henderson-Hasselbalch equation for a weak base, not a weak acid. For a weak acid, it's pH, right? If that's your thinking, then that's wrong. Because remember, for this type of chemistry, it's called acid-base chemistry, because the acid and base goes hand in hand. A weak acid will combine with water to give you a conjugate base and a proton. And pH is a reflection of the proton concentration. Now remember, these reactions don't occur in just one direction. The acid combines with the water to give you a conjugate base and a proton. But this conjugate base can also react with water to give you back the acid and a hydroxide. You see, the acid and base reaction always occur together. They always occur in opposite direction. It's not as if the acid reacts with the water to give a conjugate base and a proton, and that's it. Nope, the conjugate base can also fluctuate back into that original acid. So these reactions are always occurring in opposite directions. And at some point, they reach a point of equilibrium where these reactions are occurring at the same rate, back and forth, and they're fluctuating at the same rate at a steady concentration of acid and conjugate base. So for every acidic Henderson-Hasselbalch equation, there is a corresponding basic Henderson-Hasselbalch equation. For the acidic direction, the Henderson-Hasselbalch equation is pH equals pKa plus the log of the conjugate base over the acid. For the opposite reaction, now for the opposite reaction, going in the opposite direction, what is the Henderson-Hasselbalch equation for that direction? It will be the POH, which is analogous to the pH, right? The pH is a reflection of the proton concentration. The POH is a reflection of the hydroxide concentration. And the analog to the pKa is the pKb. pH will become POH, pKa will become pKb. And now instead of having the log of the conjugate base divided by the acid, we have plus the log of the acid divided by the conjugate base. So everything is just flipped over to its analog. And these two equations are equivalent. They describe the same phenomenon. And another thing that you must know is that the Ka times the Kb is equal to 10 to the minus 14, which is called the Kw, or the equilibrium constant of the dissociation of water. And then remember that when you talk about the pKa or the pKb, that lowercase p stands for minus the log of, and it's log base 10, not natural log. So you have Ka times Kb equals 10 to the minus 14. You want to go ahead and do minus the log of both sides, and it's log base 10. So you do minus the log of both sides, and you'll get minus the log of Ka times Kb is equal to minus the log of 10 to the minus 14. So the right hand side is equal to just 14. Okay, so minus the log of Ka times Kb is equal to minus the log of Ka plus minus the log of Kb. And minus the log of Ka is equal to the pKa, and minus the log of Kb is equal to the pKb. So we have the relationship that the pKa plus the pKb is equal to 14. So that relationship is set. The pKa and the pKb should add up to 14, which means that the pKb is equal to 14 minus the pKa. So now once we know that these two equations are equivalent and we know the relationship between the pKa and the pKb, confidently pick out the right answers. Okay, so let's go ahead and do that. Choice 1 says POH is equal to 10.2. So 10.2 should be equal to the pKb. The pKa and the pKb add up to 14, and our pKa, our given pKa, was 3.8, which means that the pKb should be equal to 14 minus 3.8, and 14 minus 3.8 is 10.2. So far so good. So POH should be equal to pKb, which would be 10.2, that's correct, plus the log of the conjugate base over the acid. That's incorrect, right? You want to flip the ratio of the conjugate base and the acid. So it should be plus the log of the acid divided by the conjugate base. So that's incorrect. The next term says the pH is equal to 3.8 minus the log of the acid divided by the conjugate base. Is that correct? The pH term is in the same place. The pKa is in the same place. The difference now is that we have minus the log instead of plus log. Is that okay? Yeah, you can change the log to minus the log as long as you also flip the ratio of the conjugate base and acid. And in this case, they actually did that, right? Okay, so that's equivalent to our given equation. That's correct. Okay, what about the next one? The next term says conjugate base over acid is equal to 10 raised to the power of the pH minus 3.8. Okay? Is that equivalent to our given equation? It looks like it is, right? They simply solve for the base to acid ratio. So those two equations are equivalent, and you need to be able to instantly recognize that. And how about the last term? So POH is equal to 10.2, okay, which will be the pKb, that's correct. So POH equals 10 plus 2 plus the log of HA over A minus. Yep. And this equation is perfectly in accordance to our given equation, right? So these three equations here are equivalent to our given equation, and you need to be able to instantly recognize that. So I hope this was helpful. If you have any questions, leave it in the comment section below. Continue to watch, continue to share. And if you haven't already, subscribe to the channel. And as always, I'll see you guys next week. Alrighty, bye-bye. Peace.